Alright guys, so I'm going to go through 7 trig proofs that I've been given online, or I've given online as well. So when you're wanting to do proofs, you really need to do them yourself before you see a solution work through. Think of it like movies, you just don't want it spoiled. As soon as you see how to do it, not only does it take the enjoyment out of getting to the solution, but it's like you can't unsee it, and it's developing those that foresight and the little tricks and the proofs that develop you into a good mathematician. So let's have a look at this one. So give it a go if you haven't already. It is sine of x times tangent of x plus cosine of x times the secant of x squared is equivalent to sine squared x plus 1 over cosine x. So we start with either side. I like to start with the left-hand side. And that's going to be, I'm not going to rewrite, usually you rewrite the first line before manipulating it, but it's right there. So I'm just going to manipulate that straight away. So that's sine of x times, and I'm going to get sine of x over cosine of x plus, and then this is cosine of x over cosine squared of x. Can you see why that's cosine x over cosine x squared? It's because that secant is 1 over cos, or 1 over cosine, so that's 1 over cosine squared. We can now write this as sine squared x over cosine x plus 1 over cosine x. So it's 1 over cosine x once we do a cancellation. Well, this is sine squared x plus 1 over cosine x because we've got the same denominator. And then the top of this is the top of that, and we have the bottom there. So that equals the right hand side, and that is the end of the first proof. Leave that there for a quick pause and a meander through the working again if anything didn't make sense. And we're on to the next one. Prove that tan x plus cotangent x is 1 over sine x cosine x. So tan is sine x over cosine x. Cotangent is the reciprocal of tan, it's 1 over tan, so we can write that as cosine of x over sine of x. And something you've done since maybe year 9 or 10 when adding fractions is creating the same denominator by multiplying by the bases. So let's multiply the top and bottom of this by sine. So I'm going to get sine squared x over cosine x sine x. Let's multiply the top and bottom of this by 1, and that 1 is going to be sine of x, cosine of x. So cosine of x squared on the top, so times by cosine, and on the bottom we're going to get cosine x sine x. Now the denominators are the same, so we can just have cosine x times sine x on the bottom, and we're going to get sine squared x plus cosine squared x on top, and we know that those add to 1. So we get 1 over cosine x sine x, and that equals the right hand side, end of proof. We could have furthered this problem. We could have said that 1 over sine and then 1 over cosine. Well, that's just going to be cosec times secant, but the problem wasn't really presented that way, so whatever. Remember, you can have this sheet in front of you at all times, right? You're allowed to have the identities. All right, this is a really cool one. I really liked what happened in this problem. It's quite unique compared to the others. So there might actually be an easier way to do it, but I went the left-hand side, which is, I'm just going to write this one out. Sine x minus 3 cosine squared x. Now I did this little trick. I turned that into -4. I I went sine squared x plus cosine squared x. So I've got the added cosine, which means I have to have negative 4, cosine squared x. Okay, well that there is 1. So I've got 1 minus 4 cosine squared x. There might be an easy way. So if I've just added cosine of x squared and taken 1 away. So that's still all the same thing. I've then found use the identity. This is now 1 minus 4 times, and I can just go 1 minus sine squared x. That's just cosine squared. So it's 1 minus 4, and negative 4 times negative sine is plus 4 sine squared x. And now I've got negative 3, so I have 4 sine squared x minus 3, which equals the right hand side. End of proof. Interesting that I think that's definitely the hardest one in this video. So, and interesting that was earlier in that problem set, because the other one's actually a lot more straightforward now, which is interesting, which makes me think that maybe I've done something a bit different in there and I'm not actually seeing the easy way forward. So let's have a look at this one. Make sure they're still lining up in the camera okay. Yeah. So this one, I feel like it's quite obvious to factorize out a cosine. So cosine, you're going to get cosine squared x plus sine squared x. That's 1. So you get cosine x, and it equals the right hand side. End of proof. Like I said, so for some reason they're getting easier. Alright, let's have a look at our formula sheet for this one. We haven't dealt with 1 plus tan squared much. 1 plus tan squared is sec squared. So I'm going to go left hand side. My table underneath is going to get a lot of LHS's engraved into it, I think. Left hand side is sec x. There, sec x. And 1 minus sine squared is, that's sec squared x. And that's cosine squared x. Well, sec squared is 1 over cosine squared times cosine squared is 1, which equals the right hand side. End of proof. So nice and easy as soon as you know to replace tan squared x plus 1 with sec squared x and 1 minus sine squared x with cosine squared x. Now remember, I'm not memorizing these, but when you've done a few, they get a little easier. That's still in the video nicely. Cool. So this one is, we're going to go left hand side, and remember 1 plus tan is sec squared, so it's exactly like that other one, where that's sec squared x, so we can have cosine squared x over cosine squared x, because that's 1 over cosine and it's squared, and that's obviously 1, so that equals the right hand side, and you're done. Again, pretty easy. Okay, I think this is the last one of today. So how are we going to do this one? Well, the left hand side, I think this one's quite easy as well. There's 1, take away sine x over cosec x. Well, that's 1 minus sine x, and remember that's divided, it's a reciprocal sign, so that's actually going to be timesing by the reciprocal, and so we get 1 minus sine squared x, which equals cosine squared of x, which is the right hand side, and we're done. So the little thing in there was sine x over cosec x. Well, cosec is 1 over sine, so if I'm dividing by 1 over sine, that's like timesing by sine itself, and then that's sine squared, and then we use the identity, and we're done.